Hello everyone, today we will be working on a very basic growth solver that you can implement in many different variations. You can grow scales on persons, grow hair on their head, etc. Because we will be working on a very simple principle. We will use noises to drive our age. That's only where we will use a solver actually. We will create noises that will decide when will this curve or this part will start growing. Then we'll use a SOP solver to only keep track of our age. Then we'll use that age to scale our curves from 0 to their end result. So for this explanatory video, I actually create a simple setup. So I'm just going to work towards it at beginning, those simple grasses here. How did I create it? I created a grid with 300 to 300 points. So many points create a better, smoother noises. I create a density noise. I generated hair looking for that density, and with a bend direction noise, a vector noise that's named bend direction, I'm bending them and setting different lengths with regarding their density. Let's go over very quickly. I'm setting length from 0.1 to 0. Maybe make it 3, that's fine as well, 0.3, and I'm using density as a skin attribute after inputting in the second input. I'm using density as well to make these smaller, keep them smaller. If I don't use it, they can get a random number between 0.1 to 0.3, so the hierarchy won't be C. To create visual hierarchy, and of course it's more accurate to the reference, we are using density as well. Then I'm using a bend operation, bending it 90, maybe make it 70 to with random of 30 randomness. And my direction attribute is bend there. I'm using a direction skin attribute mode and creating an attribute noise that's a vector showing different directions. And you can see I create the element size, and the problem actually here is, you can see here as well, there is many confusions here because this bend dir attribute is not unit length. So I can create a wrangle here. In here I'm just writing v at bend dir equals to normalize v at bend dir. This might not change many things in your setup. I think it will be helpful here a little bit at least, and then I will just set element size a little bit bigger so they work more uniformly, and that's it I think. Okay, now after creating the basic setup with grasses, we will solely focus on the grow part, and I want this to be a short video because we are just working on a simple principle, not a complex effects. So after this, I want to create a prim wop actually. So in this primitive wop, I'm just coming here. In this primitive wop, let's use our position as a color. Can we do that? Yes, we can. This is a difference between wops and wrangles. In wrangles, you can't use the v at p in a primitive. In a primitive wrangle, you need to be in a point or vertex wrangle, running over them. But in here, it makes a small calculation here to get the prim point. So I am not sure exactly which point this is, if it's the centroid of this primitive or one of the vertexes, but it saves us from a few calculations, so I'm just using this one as we are working on a still frame. Now I want a noise here to, let's use an anti-aliased noise, maybe flow noise, anti-aliased flow noise, and in here if I put it in the CD, I can see that these numerical expressions of it, we are going 0.35 and from minus 0.38. So flow noises, actually if you go to its help site, help page, you will see their ranges here. If you get into the WOPS help page, you see in here it says the noise generated is centered at 0 and typically has values between minus 0.5 and 0.5. That means if I know the range, I can fit it in another one. So minus 0.5 to 0.5 from 0 to 1. So my new colors are between 0 to 1. Nothing exceeds 0 or 1. It clamps automatically, fit range. And then I can create my noise here with this. So let's start a big noise. Maybe give it a little bit more roughness. If you want, you can do something like this as well. They will be start growing in lines, in different lines. Maybe we can try that as well later. But right now, let's make them all the same. Okay, now, how can I create an animation that's controlling my growth? We will use a compare node here. Now, compare node is just a simple if question. If input 1 is test is here, test is equal. If input 1 is equal to input 2, the output will be 1. If not, it will be 0. That's it. That's a simple if question. So in the compare, if I make it less or equal and promote a parameter to this, so I can control it from outside while watching. Give the name of grow threshold, name cannot have spaces, label can, grow threshold. Okay. Now if I go back one level, when I push this parameter, you see they start white. They start getting white. Why? Because their values are below this range and they are getting new values. Now this can be derived for an animation. So let's start from 0 to 48 and let's watch it. You see this? Well, this might be a little complicated. It won't be that fast. This will just decide when will I start to grow up, nothing more. Now we can use color as a controller, but I don't like it. I like to use visualizers and leave color alone. That's why I will bind export another parameter, that's integer parameter, that's named is growing. Now when you use is growing, maybe I need to open its okay visualizer as well. I just want to give it different random seed and okay, now green is 0 and purple is 1. You see they start growing and that's okay. Now I will create a solver SOP and control my age through this one. But in order to control it, I need to create it first, because if I create it here, it will be created every sub step of it. I don't want that. I want everything to get ready inside. So I'll just attribute create. I want a primitive attribute. I'm working on primitive level right now. The name is age. Okay. The value is 0. So I have an age attribute that's called 0. Now let's get into the solver. Now in the solver, if I take the previous frame always, so nothing changes, because previous frame 1 is outputted. In frame 2, we are looking to frame 1 and getting that output. In 3, we are looking to that looked at 1 and we are getting the first attribute always and always. So this is not how I want to use this. If I use at input 1, it's same as if we haven't used any solver. It taking the input, not the previous frame, this one, and outputting it exactly. So let's try something here. If I put a wrangle, a primitive wrangle, and if I want my age to be plussed with 0.1, let's say. If I say that, let's start. You see my age is always 0.1. Why is that? Because I am not using my previous frame. That's the simulation. That's only the most important part of the solvers as a general, because that's what makes a simulation a simulation. I need to use my previous frame. I don't want my age to be added by 1. I want my age to be what is my age in the previous frame. I want add to that and make that my new age. Let's create a float and name it prev age. And I want to put this here as well. Let's create our inputs. First of all, I'm looking at a primitive. In the first input, what was I? That's my question. What was my age in my prim number on the frame that's before? So previous age plus at time increments. Time increments means if gets to 1 with each second in a solver. If you crank up the sub steps here, time increment gets that part as well. Let's see what happens right now. If that doesn't work, we'll take something else. You see, if you keep track of age, now it's growing up. Now it's piling up. It's not still. But as you can see in the 24th frame, it's 1. In 25, it's 1.4, etc., etc. So it works, but everything is the same age. Nothing changes. Is growing attribute that we have created here does nothing. First of all, I just want to keep track of age right now. Okay. Now you see everything is aging together. Nothing changes. If I create an if statement here, if is growing, f at e at, it's an integer attribute, I at is growing equals to 1, then make my age higher and higher. If I open this, let's work right now, you see everything is aging differently. This is still not our growth. This is our age. How many seconds have I started since I start growing? I want a little bit longer right now. I want 4 seconds of animation to make them bigger. Okay. Now I have an age, so I will name this track age. This to set is growing. I will put an anim name on top of it and make it green, because animated attributes are green in my side, and that helps me keep track of them. So our age works. Now I need to make them growing up or towards that. So I'll create a simple attribute wrangle. But right now I will be working on points because I want to retract them. I can't work on whole primitive to retract them. I need each single point. I need to reach each single point and work on them. Of course, we can write a for each loop in each primitive, but I don't think that's a good idea. We can work on points. But I want my age as well. I want to use my age as well. For that, I can use a prim function, or I can promote my age to a point from the beginning. So I will use attribute promote. I want to primitive attribute to be promoted to point, and that's named age. Now this age is not a primitive attribute but a point attribute. Now when I work on growth, when I work on my points, I can use that as well. Let's just assume you want to grow with a single second, and you want to grow on top of it. Let's just first of all we create an f at grow. F at grow attribute equals to clamp f at age 0 to 1. So our age doesn't exceed 1. We have a 0 to 1 grow. Let's see. You see, when our age attribute exceeds 1, our grow sits at 1 because we are clamping it. Let's use this one first of all. For that, what can we do? We can create a vector named position and we can look for a prim UV. Now, what does prim UV do? We get an attribute on a given UV, parametric UV on a primitive. So let's open its help page. If you don't understand right away, don't be scared. Prim UV is not related with the actual UV that you use. It's a created one that starts from 0 to 1, just like curve view, but you can use prim UV in polygons as well, not just curves. But we will be using this part. You see, geometry 0. I want to look at myself. Attribute name, position, prim num, at prim num, my prim number, and UVW is this. Let's just f at curve view times crop, f at crop. Now I will show you what does this do in a second. So whenever I do this, I create a vector named pose, and if I set my position to this pose, we will have something like this. Let's see, why doesn't it work? We don't have a curve view attribute. Where did we lose it? Oh, we have never resampled our nodes. We don't have a curve view attribute at the moment. What is a curve view attribute? We have used it a lot, but if you have a curve, it puts all of the points, where is it, from 0 as a beginning, 1 and as an end. Let's resample and maybe I can show you some here like this. If I create a curve view attribute and visualize it, you see bottom roots are 0, and as you get to the tip it gets to 1. So we will be using this. I want 10 points each, and that's it. We can use it after the edge, of course. We can use something like this. Yes. Now when I open the grow attribute, let's go. You see we are starting to grow. Now this particular calculation, this equation might confuse you, but actually we are doing this. So we are, let's say we are on the tip of this curve, okay, this graph, but our age is halved. So it's only been half second. We can't be there. We need to be halfway there. So we are pushing our age and curve view. So on the top point, it says 1 times 0.5. So it gets to half. But on the point that's half, it needs to go to 0.25, right? So that's why we are multiplying curve view with grow. If, well, this verbal explanation might not be enough for that. So let's actually make a quick explanatory line for that. I want you to understand this. So let's create a noise. With noise, just make it 20 points, maybe 21. With resample node. Actually, I want to use a resample node to get a curve view as well. It's curve view. Okay, now in here, if I use the vector, I want to p at positive, 0 centered. Okay, we have a curve like this, let's say. Okay, we have a curve like this. Well, I want to play along with it like this. Okay, now we have a curve like this. These are our points, right? Let's create a wrangle at the bottom of it. Let's resample it later on. Now we will be working on better, yes. Now in this resample, if I open curve view, let's open the visualizer, curve view. Okay. Now you see it's 0 and going up to 1. Oh, let's float bias equals bias, and let's create the same thing. Vector pose equals prim UV 0 position at prim num. Actually, there is only one prim, so I'm not going to use it. And bias times f at curve u. V at p equals pos. Now, let's take this bias towards 1. Now, can you see what we are doing? Well, let's say we are going to 0.6. And I just want to clone it and make it 1 to make it as a template. Okay, now, you see here, now my top point was here. Its curve u was 1 and its bias was 1. But when I retract the bias, this point comes to the 0.6, right? But for the middle part, you see in here, let's say this is the point you want to refer to. So this point can't stay in that part as well. It can't stay here or here or here as well. It needs to retract all together. So I was the half point of it. If top is here, I need to be half of that as well. That's why I'm multiplying my curve u with my bias. So in the single setup, if you write this, you can see simple explanatory parts of it. You see this. This single equation helps us create this. So actually, I've seen this one of the John Kunz's streams. You can check it out as well. If I can find the right video, I will put a link below. So let's see. We use that equation, that simple function actually, to grow our curves. But you see this is not enough for us. Why? Because we might not want to use age as well. If we don't want to grow in 1 second to completion, or if we want to use another noise, or if we want to differentiate something, what should we do? We can actually do this. In the clamp, we can divide age with some number. That's an explanatory. That's the way. If I divide age by 2, now I will grow in 2 seconds. You see, because when my age becomes 2, 2 divided by 2 becomes 1. That's when my growth will be 1. You see, that's twice as slow. Maybe if I multiply age with 2, I will grow in half a second. You see, way faster. If I want to create a randomization, I can use a fit01 function here. Fit01 rand at ptnum, at primnum actually, at primnum. And I want that to be between 2 to 4. So you see, I will grow between half and quarter of a second in this setup. It will be so fast. And also, this is not a simulation anymore. You don't need to go to the solver again. So you can check it out in real time with no hesitation, or don't need to recache all the time. You see, this is even better. So in this part, everything is controlled by your age and the calculations you've done with it. You can create a temporary float that is age multiplier, or you see, we can make this calculation here in different parts. We can make this a variable and write that variable's name here, temp. You see, that's it. As long as you change temp, your speed will change. After this, it's all up to you how you use it, but this is the main equation. That seems a little bit complicated, but actually not that much. More you look at it, more you try at it, you'll get more hang of it, and you start to understand how it works. This setup can help you as well. So today's video is over with this. Let's color it and create our regular. Oh, that's too much color. Yes, that's better. And why is this light background? I always use dark. Okay. Let's end this lesson with more grass. I will crank up density a little bit higher. Well, 3 times higher. And let's see. Let's end with a flip. So today, as I said, this is I'm not trying to make you create this complex effects, or I don't want this to become a mathematics tutorial as well. I just wanted to show you that there is a simple algorithm that you can make it work, that you can make work for different parts as well. I use this same simple setup to grow scales on a skin, or grow hair on someone. Again, on a magical effects to grow this grass from the underground on a life spell, etc., etc. So these all can vary very differently, but the simple setup is the same. For growth, you can use H. Oh hell, you can use distances. There's a talk again of Corbin Main and Urban's, the Double Jump Academy's co-founders. I think I will put a link down below as well. On the second part of it, you can see Corbin Main creating fantastic setups as well. But if you've reached to this tutorial, I believe you already watched it. It's released soon. So we can end it here today. Thank you for watching and hope this helps you a little bit. Have a nice day.